Okay, let's see. Picking up where we left off. All right, let's look at these directions. They say find the exact value of the log without a calculator. All right, so what should be our approach to the directions of finding the exact value without a calculator? All right, we can try and find the answer mentally, knowing that 3 is the base of an exponential. So 3 raised to what power is 9? This one we can do mentally. 3 raised to what power is 9? Well, that would have to be 2. So you can go straight to the answer. But what happens when they get a little more complicated? We need a strategy to fall back on to find these answers. All right, so we're going to show you the strategy that gets you the answer of 2. For these kinds of problems right here, you might want to first change the logs to an exponential equation. To do so, you might want to just set the log expression equal to x. Think about our previous work of changing from log form to exponential form. The exponential form of this equation would be 3 raised to the x power equals 9. All right, well, the visual here, as we can see it, that x has to be 2. But what happens later when it's not so obvious? Well, I'm going to continue with this strategy that supports my answer of 2. So I noticed that, that 9 can be rewritten as a power of 3. 9 can be rewritten with the same base as what I have over here. 9 is actually 3 squared. When we're down here to this line, if we have the same bases, then the exponents have to be equal. I mean, there's no way you can have equality with the same bases unless these exponents are equal. So what happens is these bases fall out, and we just look at the exponents and we set them equal to each other. Well, you're done. X is by itself, so my answer is x equals 2. Right, and the reason I shared this strategy with you is because look at number 2. All right, if we have to find this answer without a calculator and I see this decimal, I'm going, wow, that's a lot. And certainly I can't think in my brain 4 raised to what power is 16 raised to the 3.4 power. All right, so how do we solve this without a calculator? Set it equal to x. We're trying to find some answer that this is equal to. Change to exponential form. So start with the base on the log. 4 raised to what power of x is equal to this whole argument here. 16 raised to the 3.4 power. Okay, well, that might not look like it's any easier, but our objective is to get the same bases. Well, I see that 16 can be rewritten as a power of 2. So bring down 4 to the x equals, let's go ahead and rewrite 16 as 4 squared. So I'm going to change 16 to 4 squared, but remember I still have an exponent of 3.4. Okay, a little more work. Bring down 4 to the x equals, all right, from algebra 1, we have a power to a power. So the property of exponents says that we're going to multiply these two exponents together. So keep the base of 4. I don't need a calculator to multiply 2 times 3.4. My new exponent would be 6.8. Okay, at this line, notice what you have. You have the same bases. They fall out. So take the exponents, set them equal. So my answer is x equals 6.8. All right, let's look at number 3. 2 raised to what power is negative 4? That's what that log means because it's an exponent. What's the exponent on 2 that gets you negative 4 as an answer? I'm hoping some of you are thinking in your brain, well, there's no way you can get a negative answer when you take 2 to a power. Well, if that can't happen, the answer should be no solution. But just for the sake of practicing the strategy, okay, let's set that equal to some number x. Let's change to exponential form. 2 to the x equals negative 4. Well, right here, hopefully we're seeing again that there's no way I can find a value for x that's going to give me a negative answer. So you're pretty much out of the problem. That's a circle with a line through it, and that's an official symbol in math, and it represents no solution. There's no answer to this problem. this expression right here, okay, would need to be positive for me to find an answer. All right, let's look at number 4. If you can do this one mentally and think that the answer should be 3, great, you're done. You don't need to show the work that supports it. Again, remember, the answer to this is 5 raised to what power is 125? I'd have to take 5 to the 3rd power to produce 125. If you can go straight to 3, box it, you're done. Otherwise, set the log expression equal to x, change to exponential form. 5 to the x equals 125. Rewrite 125 as a power of 5. Well, 125 is 5 cubed. Notice the bases are the same, they fall out. If they're not the same, they don't fall out. Set the exponents equal to each other. The result is 3, like we already knew mentally. All right, number 5. Okay, notice how we're changing from L Ogis to a natural log. All right, so some of our past work, you might identify natural log and e as canceling each other. That's great if you do. Could I use this previous strategy? Sure I could. I could write in a base of e here if I wanted to. But each and every problem you need to just kind of tackle individually and look at it and go, well, what do I know? Is it like the last one? Is it different? What can I apply? So for number 5, I'm not going to use the previous strategy that I've been using. I'm going to notice that natural log and e undo each other. They're inverses, natural log, natural exponential. So the result of this expression right here is just 4. Well, I still have the 2 in front, so I've got to multiply 2 times 4. The final answer is 8. I'm not going to do this exponential work right here if I see that some other properties can be used. All right, let's look at 6. All right, I have a natural log and a natural exponential. The problem is the natural exponential isn't right next to the natural log to where I can do some canceling like it was here. So let's do a rewrite to get e right next to natural log. Okay, I know the square root of e can be rewritten as e to the 1/2. That's a 1/2. Okay, I'm going to continue the rewrite and bring e out of the denominator, but when I bring e up out of the denominator, I have to adjust the positive 1/2 to a negative 1/2 exponent. Okay, at this point, I have the natural log followed immediately by the natural exponential. They drop out, so to speak, undo each other, and I'm left with just the exponent because of my previous work with log properties. All right, let's look at number 7. All right, we've got a couple of different approaches on this one. Okay, probably the easiest approach would be like what we did on 5 and 6. All right, let's look at this term and this term, see if we can simplify each of them, and then go from there. Natural log of e, undo each other, we're left with 3. Okay, bring down the minus, natural log of e, and the 7. Well, we still have the 2 in front, but the result of simplifying this expression right here is 7. 3 minus 14, final answer, negative 11. All right, that's one strategy. Okay, to help us with our work coming up, here's another strategy, and also to help us with this next problem over here. I want to share with you guys another way to get negative 11. All right, I'm going to write down the original problem again since I kind of butchered it over there. Okay. Now don't get me wrong, I'm certainly going to use this approach right here because that's the most straightforward and simple, but I want to involve something that we just saw in this video, and that's the log properties. All right, I see a minus with 2 ln's. Okay, the minus with the 2 ln's tells me that I might be able to use the quotient property that we just practiced in the last video. Well, I can't build a fraction with one ln unless I get rid of the 2. Well, let me bring down ln of e cubed. But what I'm going to do is I'm going to use the power property from earlier, and I'm going to bring the 2 back on to e to the 7th as an exponent. So I'm going to have minus, and then I'll have the ln because I'm about to move the 2, and I'll put it back up here in the power position. Bring down the ln e cubed minus ln, I don't know why sometimes I do a cursive and sometimes not. Okay, power to a power, that'll become 14. Okay, at this point you can probably see that you can cancel the ln e here and still have 3 minus 14. You can jump off the problem right there, or you can apply the quotient property, collapsing this, doing just the opposite of what we did earlier by expanding. Okay, rewrite this as one log expression. The minus means build a fraction, put e cubed on top, and e to the 14th on bottom. Okay, well, if you were to subtract these exponents from the properties from Algebra 1, you would have natural log of e, 3 minus 14 is negative 11. All right, now back to the log properties. These undo each other. My final answer is negative 11. So I got the same answer by doing a ton more work. I would choose this approach over here, but just seeing this approach is going to help us with number 8. All right, number 8. Okay, 5 to what power is 375? I have no idea. 5 to what power is 3? Have no idea. If I could individually simplify these, I would, but I don't see what I can do. All right, nothing cancels like it did in number 7 where I had the ln and the e together. I do notice that both these terms have a log base 5, and I have a subtraction. So I can actually rewrite this using the log properties, but go in the reverse order and not expand, but collapse. So with a minus, I'm thinking a quotient, building a fraction. Log 5, put 375 on top because it comes first in the first term, and 3 on bottom. Sometimes we say this is just collapsing, condensing. So this expansion came from this quotient. So what do we do here? Well, there's not much, but I know I could probably simplify this. This simplifies to 125. Where I'm at, I saw previously in problem number 4, 5 to what power is 125? 3. I don't know, every problem's a little bit different. Okay, if I see multiple log terms, one of the strategies I think of is collapsing it by using the log properties. If I only see one log expression, then I'll probably change to an exponential and try and solve it by getting the same bases and equating, putting the exponents equal. If I see a natural log, I might think about the other log, basic log properties of canceling. So really every single problem is just a little bit different, and you just have to focus on the strategy that's going to solve the problem for that particular one.